Hello everyone, welcome to my YouTube channel Target 100 in Mathematics by Shivesh Kumar Singh, and today we are going to discuss the topic differentiation, which is very important topic of calculus. In my another videos I have explained you about continuity, limits. Please try to watch that video if you have missed that. Now let's start the lesson. See, what's the meaning of differentiation? Differentiation means it is the rate of change of one quantity with respect to another quantity. Okay, so simple meaning of derivative is rate of change of one function, rate of change of one function or quantity with respect to another quantity or another function, or you can say another variable. Okay, for example, if I say y is any function of x, then you will write it like this: y is equal to fx. Then rate of change of y with respect to x, it will be called derivative of y with respect to x, and it will be written by dy by dx, and it will be denoted as f dash x. Okay, now we use various denotions for the derivative. First, this is very common, dy by dx is very common denotion, that is differentiation of y with respect to x, or you can say y1, or you can say y dash. All the meanings are same. Okay, and all it means is derivative of y with respect to x. It can be any variable, not necessarily to be y and x, but yes, normally we write it as x and y. Okay, now to apply the derivative or to find the differentiation of one function with respect to another function, or one variable with respect to another variable, you will have to remember and understand, memorize little formulae. And what are those formulae? I'll try to write all the formulae together at one screen only, so that you can take the screenshot of all these things. First is derivative of x to the power n. It will be equal to n x to the power n minus 1, where n is a real number. Then derivative of a to the power x, it will be equal to a to the power x into log a, where a is, of course, it is positive because log cannot be defined for the negative numbers. Then derivative of e to the power x will be equal to e raised to the power x. Okay, now you see, if you want to derive all these formulae, then you will have to see that video where I have explained about differentiability and first derivative method. Okay, then by that you can see that how we can find the derivative formula for any function. Okay, now next can be differentiation of sine x. It will be equal to cos x. It is not the integration, it is differentiation. So this is derivative of sine x is cos x. Then derivative of cos x will be equal to minus sine x. Then derivative of tan x will be equal to sec square x. Then derivative of cot x is equal to minus cosec square x. Okay, my dear students, remember one thing, that at some places cosec is written like this also. CSC is also called cosec. Okay, so try to understand these things. So derivative of cot x is minus cosec square x. Then derivative of sec x is equal to sec x into tan x. Derivative of cosec x is equal to minus cosec x into cot x. These are for the differentiation of trigonometric function. Now what about inverse trigonometric function? Derivative of sine inverse x is equal to 1 upon under root 1 minus x square. Derivative of cos inverse x is equal to minus 1 upon under root 1 minus x square. Derivative of tan inverse x is equal to 1 upon 1 plus x square. Then try to understand this last one because it's going to be little smaller. Derivative of sec inverse x will be equal to 1 upon x root x square minus 1, and derivative of cosec inverse x will be equal to minus 1 upon x root x square minus 1. These are the basic formulae of differentiation. Okay, if you will memorize these formulae, then questions will be very easy for you to solve. Now, after this, we are going to see some properties related with the differentiation. What are those properties? If fx and gx be two functions, differentiable functions of course, then what we are going to see here, first property can be derivative of fx plus minus gx, means if you have to differentiate addition or subtraction of two functions, then what it will be? It can be differentiated separately. So it will be derivative of fx plus minus derivative of gx. Okay, like this you can understand and memorize the properties. Now, another property can be derivative of, or we can discuss the example also. For example, suppose we want to solve this question, derivative of, say for example, sine x plus x to the power 10. Okay, you can pause the video and try to find its derivative and write the answer in the comment. This can be derivative of sine x plus derivative of x to the power 10. Okay, now this is derivative of sine x is what? Cos x, and derivative of x to the power 10. So here you will apply this formula, n x to the power n minus 1. Okay, so it will be 10 x to the power 10 minus 1 means 9, and this will be the answer. Okay, like this you can apply this property of addition or subtraction. Now similarly, if you have to differentiate product of two functions, that is derivative of fx multiply gx, then what you can do here, formula is fx times derivative of gx plus gx times derivative of fx. Now here as example, for example, suppose we have to differentiate x to the power 5 times tan x. So what we can do here, we can do x to the power 5 times derivative of tan x plus tan x times derivative of x to the power 5. Now x to the power 5 as it is, derivative of tan x will be what? Sec square x, and then tan x times derivative of x to the power 5 will be 5x to the power 4. If you can take something common, for example, here you can see x to the power 4 can be taken common, so you will take it common. X to the power 4 times it will be x sec square x plus 5 tan x. This will be the answer of this question. Okay, so these are the two properties. Similarly, now if you want to divide, or if you want to differentiate the division of two functions, then what you will do? Derivative of fx over gx, then it will be denominator into differentiation of numerator minus numerator into differentiation of denominator upon denominator whole square. Okay, like this, the way I am speaking, if you will memorize the formula, don't muck up in the form of fx and gx only, because maybe in some questions you will see they will write gx in numerator and fx in denominator. Okay, so if you will remember in terms of numerator denominator, then it will be easy and good for you. For example, suppose we want to differentiate this function e to the power x upon, say, cos x, then what it will be? Denominator into derivative of numerator minus numerator into derivative of denominator cos x over denominator whole square, means cos square x. So it will be cos x into derivative of e to the power x, means e to the power x minus e to the power x. Derivative of cos x is what? Minus sin x over, it will be cos square x. Now what we can see here, in numerator we can take e to the power x common, and now I am separating the terms, means cos x upon cos square x, just to simplify this, okay, because sometimes they want complete simplification of the expression. Minus times minus will become plus, and it will be sin x upon cos square x. So cos square x, I am writing cos x into cos x, okay. Now it will be e to the power x times, see, one time cos x will be cancelled out, and it will be left with 1 over cos x. 1 over cos x means sec x, plus sin x upon cos x it will be equal to tan x, and 1 upon cos x will be equal to sec x. So what you can see here, sec x also can be taken common. So what it can be? It can be written like this also, e to the power x into sec x times 1 plus tan x. Okay, like this you can solve the question. Like this you can apply the property. Now next property can be derivative of any constant k will be equal to 0. Here k is any constant, and if this constant is multiplied by any function k times fx, if you have to differentiate, then constant can be taken out and variable part will be differentiated. Again here k is a real number, okay. Like first example can be, if you want to differentiate, say for example 5, so its derivative will be equal to 0. Why? Because 5 is a constant number and constant things doesn't change, and I have told you derivative means rate of change of one quantity with respect to another quantity. So if anything is constant, then it will not change, so its differentiation will be 0. And if it is multiplied with any number, for example, say we want to differentiate 2 tan inverse x, then what it will be? See, 2 is a constant, it will be taken out and variable part will be differentiated. Now this is 2 times 1 upon 1 plus x square. Okay. Now remember one thing, that if you have question like this, derivative of tan inverse 2x, then 2 cannot be taken out. Why? Because 2 is not independent here. Here 2 was independent, so it goes out here. But here 2x, 2 is inside the tan inverse, so it cannot go outside. So how to differentiate this? This we will see in another lesson, where I will explain you about the chain rule. Okay, that is another important property of derivative. So far you can memorize these properties and formulae also. And now you see, the best thing for differentiation is no need to see the book even for the practice. Just write any question yourself. For example, you can write x to the power 100 plus 5 e to the power x plus 7 sec x plus 9 tan inverse x, and differentiate it. Okay. So what it will be? It will be x to the power 10 derivative, 100 derivative will be 100 x to the power 99 plus 5 will remain as it is. Derivative of e to the power x will be e to the power x, no change in derivative. Now 7 times sec x, so 7 will remain as it is, and derivative of sec x will be sec x into tan x, plus 9 will remain as it is, and derivative of tan inverse x will be 1 upon 1 plus x square. Similarly, you can practice this question also, cosec x plus 5. Okay. So derivative of cosec x is minus cosec x into cot x plus derivative of 5 will be 0. Okay. So like this you can practice so many questions of derivative, and this is very easy and important topic. Why it is very important? Because its reverse process will be used in integration also. So it's better for you that before starting integration you just finish differentiation by all means, by all practice. Okay, so that integration will be very easy for you. I am sure you understood this lesson and you understood all the formula and method. If you have any problem, you can write in the comment, then I'll try to explain my level best. Okay, and if you think that such videos will help you to increase your knowledge, please like and subscribe my channel and share with your friends also. Thank you.